Today we are going to discuss some of the important questions of the 5th chapter of your chemistry syllabus, that is surface chemistry. According to the blueprint, the surface chemistry chapter has got a weightage of 6 mark. One mark question will be appearing from part A, one 5 mark question will be appearing from part D. Totally, if you consider, the surface chemistry chapter has got a weightage of 6 mark. And it is the very simple and theoretical chapter. And if you understand the concepts regarding the chapter, you can easily answer the questions when it comes in the final board exam. Now, children, let us move towards the chapter that is surface chemistry. When you see the word surface chemistry, it is a branch of chemistry which deals with the phenomena or the processes that are taking place on the surface of the solid substance. Such a branch of chemistry is regarded as surface chemistry. And when you think of the processes like corrosion and catalytic processes and electrode processes, all these processes will be the processes which are taking place on the surface of the solid substance. Then what is the process actually taking place in the surface chemistry? It is the adsorption process that is involved in surface chemistry. What is adsorption? Adsorption is a process of accumulation of the molecules of gas or the liquid on the solid surface. Such a process is regarded as adsorption. When you think of adsorption, two terms comes to your mind. One is the adsorbate, the other one is the adsorbent. What is adsorbate? Adsorbate are the molecules of the solid liquids or the gases which are going to accumulate on the solid surface. They are regarded as adsorbates. When you think of adsorbent, it is the surface of the solid on which the accumulation of the molecules of gas or the liquid will be taking place. Such a surface is regarded as adsorbent. If I need to tell you that, let me take an example here, children. That is the accumulation of ammonia gas on the charcoal. And if you consider the ammonia gas, it is going to act as an adsorbate. And when you think of charcoal, here the charcoal is acting as the adsorbent. The ammonia gas is getting accumulated on the surface of the charcoal. So ammonia is acting as the adsorbate and the charcoal is acting as the adsorbent, where the adsorbate is getting accumulated on the surface of the adsorbent. This entire process is regarded as what is known as adsorption. Now let us move towards the important questions one by one, children. And if you consider the first question here, the first question is, what is the change in enthalpy, entropy and Gibbs free energy of when a adsorption of a gas on a solid is taking place? In yav thara change agutte? Enthalpy, entropy matte Gibbs free energy yav thara change agutte when a process of adsorption is taking place? That is the question here. Let me tell you, children, here when you consider the surface of a adsorbent, the adsorbent has got the molecules which are free and have the unsatisfied force of attraction. And here towards the solid surface, the adsorbate molecules are coming towards the solid surface such that they are getting attracted by the molecules which are present on the surface of the adsorbent. When the molecules of the adsorbate are getting attracted by the molecules which are present on the adsorbent, the adsorbate molecules will be adsorbed on the surface of the adsorbent. If such a thing is taking place here, the adsorption process is regarded as a exothermic process. Exothermic process andre ಏನು? Exothermic reaction andre ಏನು? The reaction in which the energy is released in the form of heat. Such a reaction is regarded as exothermic reactions. And here I have already told you that adsorption is a exothermic process. some amount of energy is getting released in the form of heat here. So if such is the thing taking place there, the change in enthalpy ಏನಾಗುತ್ತೆ, let me write that. I'm going to mention the change in enthalpy by writing delta H, and the delta H is going to decrease, ಕಮ್ಮಿ ಆಗುತ್ತೆ. Okay, then what happens with that of entropy? Entropy ಅಂದ್ರೆ ಮಕ್ಕಳ, it is the measure of randomness of the particles. It is the measure of degree of randomness of the particles, that is regarded as entropy. And here we are going to denote the change in enthalpy by writing delta S. When the molecules of the adsorbate are randomly moving in the atmosphere, they have got the more entropy. But when those molecules are getting adsorbed on the surface of the adsorbent, they are getting accumulated towards the solid surface. Thereby the measure of randomness or random movement of the particles are getting decreased here. Even in the case of change in entropy, it is also going to decrease when the adsorption process is taking place. Then what happens with that of Gibbs free energy? Gibbs free energy, the change in Gibbs free energy will be denoted by writing delta G. Delta G na bardu denote ಮಾಡ್ತೀವಿ. All the adsorption reactions that are taking place are spontaneous in nature. When for the spontaneous reactions, the delta G is going to decrease. When you consider all these three, that is change in enthalpy, change in entropy, as well as change in Gibbs free energy, they are going to decrease and they are going to have the negative values. You can just simply say that the delta H, delta S, and delta G all are negative. Hope you got to know about the first question, children. Let us move towards the second question now. When you consider the second question here, the second question is regarding write the differences between physisorption and chemisorption. When you consider these two types of adsorptions, there are the types under the adsorption. One is the physisorption, the other one is the chemisorption. When you consider the physical adsorption is shortly called as physisorption. When you consider the physical adsorption, the molecules of the adsorbate are held on the surface of the adsorbent with the help of weak van der Waals force. Weak van der Waals force illi operate agutte. And when you think of the physical adsorption, they are reversible in nature. Once they get adsorbed on the surface of the adsorbent, they can easily be removed back. Adana vapas navu remove ಮಾಡಿ adsorbate na as such navu remove ಮಾಡಿ adsorbate state ge idbodu, ಮತ್ತೆ adsorbent nu kuda as such navu idbodu. That is what is regarded as they are reversible in nature. And when a process of physical adsorption is taking place on the surface of the adsorbent, multi-molecular layers will be formed. Andre a large number of layers of the adsorbate will be formed on the surface of the adsorbent. These are the points you can write under physical adsorption. When you think of chemical adsorption, here the molecules of the adsorbate are held on the surface of the adsorbent with the help of strong chemical bond. Strong chemical bond in the adsorbate the molecules ಮತ್ತೆ adsorbent the molecules held ಆಗಿರುತ್ತೆ. And when you think of the enthalpy of adsorption, they have got higher enthalpy of adsorption. And since the bonds which are formed in the case of chemical adsorption are strong, they are irreversible in nature. Once the adsorption process takes place, we cannot reverse it back. That is what it is saying. And when the chemical adsorption will be taking place, there will be formation of monomolecular layer on the surface of the adsorbent. These are the points you can write under chemical adsorption. Hope you got to know about the differences between physical adsorption as well as chemical adsorption. Now, children, let us move towards the next question. The next question is regarding the differences between lyophilic and lyophobic colloids. First, let me tell you what are colloids. Colloids andre enu anta heltini makla. When you take a spoonful of sugar and add it to the water ge add ಮಾಡಿದಾಗ makla, and the solution that is formed there is a homogeneous mixture, because the sugar particles are invisible in the water. That's why that mixture is regarded as homogeneous mixture, and the particles present there are regarded as the true solution particles ಅಥವಾ crystalloids ಅಂತ ಕೂಡ ನಾವು ಮೆನ್ಷನ್ ಮಾಡ್ತೀವಿ. Okay, and if you think of a mixture or a solution containing a handful of salt, if you consider a handful of sand and if you are going to add it to the water, so the particles of the sand will be settled at the bottom of the beaker, and there if you consider, those particles are regarded as the suspensions anta kariತೀವಿ. When you think of true solution particles, they have got the diameter of less than 1 nanometer. When you think of suspension particles, they have got the diameter of more than 1000 nanometer, because those sand particles will be visible to our eyes. When you look at a sand solution, the sand particles will be settled at the bottom. That can be easily seen through our eyes. Okay, and what are colloids here? Colloid is a third type of the particle which is having the diameter between 1 nanometer to 1000 nanometer. Those particles will be regarded as the colloids anta ನಾವು ಅದನ್ನ ಕರಿತೀವಿ. Okay, and when you think of the colloids are classified into different types based on the affinity between the dispersed phase and the dispersion medium, based on the particle size. Particle size ಮೇಲೂ ಕೂಡ ನಾವು colloids in a further classify ಮಾಡ್ತೀವಿ. When you think of the classification of colloids based on the affinity between the DM and DP, you might be thinking of what is DM and what is DP. DM andre makla, it is dispersion medium. DP andre it is dispersed phase, the continuous phase in which the colloidal particles are dissolved, that is regarded as dispersion medium. And those colloidal particles which are dissolved in the continuous phase, they are regarded as dispersed phase. Hope you got to know about what is DM and what is DP. And here, children, based on the affinity between the DM and DP, the colloids are classified into two types. One is the lyophilic colloid, the other one is the lyophobic colloid. When you think of lyophilic colloids, there is a strong affinity between the DP and DM. There is a strong force of attraction between the dispersed phase as well as the dispersion medium in the case of lyophilic colloids. And the best example for the lyophilic colloid is the starch solution. Okay, and when the lyophilic colloids are formed here, they are going to exist stably. A lyophilic colloids in form agutte, those colloids are going to occur stable agi adu exist agutte, and they are reversible in nature. When you form the lyophilic colloids, they can be reversed back to their existence. Adradu ಏನ್ existence ಇತ್ತು ಅದೇ ತರ ನಾವು ಅದನ್ನ reverse ಮಾಡಬಹುದು. They are called as reversible in nature. Okay, these are the points you can write under lyophilic colloids. When you think of lyophobic colloids here, lyophobic colloids andre makla, here the colloids in which there is no affinity between dispersed phase and the dispersion medium. Dispersed phase madhya ಮತ್ತೆ the particles of dispersion medium madhya ಯಾವುದೇ ತರದ affinity ಇರಲ್ಲ. Such type of colloids are regarded as lyophobic colloids, and the best example for the lyophobic colloid is the gold sol. And when the lyophobic sols are prepared here, they are less stable in nature. Tumbane stable agi adu exist agalla, only to a certain extent they'll be stable. Okay, when the lyophobic colloids are prepared, they cannot be reversed back. It can be regarded as they are irreversible in nature. Hope you got to know about the differences between the lyophilic colloid as well as the lyophobic colloids. Now children, let us move towards the next question here. The fourth question is regarding write the expression for Freundlich adsorption isotherm. What is adsorption isotherm? Let us first understand regarding what is adsorption isotherm here. When you think of adsorption isotherm, it is a graphical representation which relates the extent of adsorption on the surface of the adsorbent versus the pressure ಗೆ relate ಮಾಡುತ್ತೆ. Such a type of graphical representation is regarded as adsorption isotherm. When you consider the adsorption isotherm, there are two types of adsorption isotherms. One is the Freundlich adsorption isotherm, the other one is the Langmuir adsorption isotherm. When you consider the Freundlich adsorption isotherm, the question is write the expression for Freundlich adsorption isotherm. Freundlich adsorption isotherm says that x by m is equal to k into p to the power 1 by n, where n will be having the value always greater than 1. What is this terms are indicating? When you think of x is the mass of the adsorbate. Andre the mass of the accumulating particles will be denoted by writing x. When you think of m is going to denote you the mass of the solid surface. ಆ ಒಂದು adsorbent the mass ನಾವು m ಅಂತ ಬರ್ತು represent ಮಾಡ್ತೀವಿ. And here k and n are the constants used here, and p will be representing the pressure here. And the extent of, according to Freundlich adsorption isotherm, the extent of adsorption on the surface of the adsorbent will be directly proportional to the pressure. That is what the Freundlich adsorption isotherm is telling you. Now children, let us move towards the next question here. The next question is regarding what is multimolecular, macromolecular as well as associated colloids. As I already told you children, the colloids are classified into different types. Bere ways mele bere types agi adanna classify madidare. When you think of the particle size, a size of the particles mele neevu think maddaga, the colloids are classified into three types. One is the multimolecular colloid, the other one is the macromolecular colloid, and the third one is the associated colloid. What is multimolecular colloid? These are the colloids which are formed by the aggregation of the particles, aggregation of the molecules which are having smallest size. Small size iranta particles aggregate agutte. Large number of small particles will be aggregating together to form a colloid. Such a colloid is regarded as multimolecular colloid. Then what is macromolecular colloids? Macromolecular colloids andre makla here, these are the colloids which are formed by the aggregation of large number of molecules which are having larger size. Size ಜಾಸ್ತಿ ಇರೋಂತ particles, large number of particles aggregate ಆಗುತ್ತೆ, aggregate ಆಗಿ ಒಂದು colloid ನ form ಮಾಡುತ್ತೆ. Such type of colloids are regarded as macromolecular colloids. Then what is the third type? That is associated colloids andre ಏನು? Associated colloids andre makla here, large number of particles having intermediate size. Intermediate size andre they are not going to have either the small size or the biggest size. Their size will be between those. Small ಮತ್ತೆ big ಗಿಂತ ಮಧ್ಯದಲ್ಲಿ ಅದರದ್ದು size ಇರುತ್ತೆ. Those particles, when they are in the lower concentration, they are going to just act as the electrolyte. Electrolyte ಆಗಿ ಅದು act ಮಾಡುತ್ತೆ. But when those particles which are at higher concentration ಜಾಸ್ತಿ ಇರಬೇಕಾದ್ರೆ, they'll be aggregating together to form the colloidal particles. Those colloidal particles are regarded as associated colloids. Hope you got to know about the fifth question, children. Now let us move towards the next question. The sixth question is regarding what is peptidization. Give an example. When you think of peptidization, it is a method for the preparation of the colloids. Colloids na prepare madlikke a lot more number of methods are used. Among those, this peptidization is one of the method for the preparation of the colloids. And peptidization is the process of converting the freshly prepared precipitate into colloidal salt. ಹೇಗೆ ಪ್ರಿಪೇರ್ ಮಾಡ್ತೀವಿ? How do we prepare the colloidal salt from the freshly prepared precipitate? By adding small amount of suitable electrolyte. When you are going to add a suitable electrolyte to the freshly prepared precipitate, that freshly prepared precipitate will be getting converted into the colloidal salt. Such a process of preparing the colloid is regarded as peptidization. And what is an example for that? When you consider the example, freshly prepared ferric hydroxide precipitate is treated with ferric chloride. This ferric chloride is acting as an electrolyte here, and this freshly prepared ferric hydroxide precipitate ige ferric chloride ಅನ್ನೋ ಒಂದು suitable electrolyte ನ add ಮಾಡಿದಾಗ ferric hydroxide ಅನ್ನೋ ಒಂದು colloid ಅಲ್ಲಿ prepare ಆಗುತ್ತೆ. Hope you got to know about the sixth question, children. Now let us move towards the next question. The next, the seventh question is regarding what is dialysis. Explain how it is used to purify colloidal solution. Dialysis andre makla ee word ಬಗ್ಗೆ ನೀವು ಕೇಳಿರಬಹುದು. Dialysis process na usually kidney failure ಆಗಿರೋರಿಗೆ ಯೂಸ್ ಮಾಡ್ತಾರೆ. This is the process which is employed in order to purify the blood in the case of those patients which are suffering from kidney failure. Okay, and what is this dialysis process? Dialysis ಅನ್ನೋ word colloids ಅಲ್ಲಿ ಯಾಕೆ ಬರ್ತಿದೆ ಅಂತ ಹೇಳಿದ್ರೆ, this is the process which is employed in order to purify the colloids. Even in the case of colloids, colloidal solution ನ purify ಮಾಡ್ಲಿಕ್ಕೋಸ್ಕರ ನಾವು ಈ dialysis ಅನ್ನೋ ಒಂದು process ನ ನಾವಿಲ್ಲಿ employ ಮಾಡ್ತೀವಿ. Okay, then what is dialysis actually? It is a process of removing the true solution particles. ಅದನ್ನ ನಾವು ಇನ್ನ ಒಂದು ವರ್ಡ್ ಇಂದ ಇಲ್ಲಿ ಡಿನೋಟ್ ಮಾಡಿದೀವಿ, that is dissolved substances from the colloidal solution by means of a diffusion. through a suitable membrane ಮುಖಾಂತರ ನಾವು ಈ ಒಂದು process ನ carry out ಮಾಡ್ತೀವಿ. It is a process of removing the true solution particles from the colloidal solution by means of a process called diffusion through a suitable membrane. That is regarded as dialysis. Then how it is used to purify the colloidal solution? ಕೊಲಾಯ್ಡಲ್ ಸೊಲ್ಯೂಷನ್ ನ ಪ್ಯೂರಿಫೈ ಮಾಡ್ಲಿಕ್ಕೆ ಡಯಾಲಿಸಿಸ್ ಪ್ರಾಸೆಸ್ ಹೆಂಗೆ ಹೆಲ್ಪ್ ಮಾಡುತ್ತೆ ಅಂತ ಹೇಳೋದಾದ್ರೆ, ಯೋ ಮಕ್ಳ, ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಕನ್ಸಿಡರ್ ಅ ಬ್ಯಾಗ್ ಹಿಯರ್. ಒಂದು ಸೂಟಬಲ್ ಅನಿಮಲ್ ಮೆಂಬ್ರೇನ್ ಇಂದ ಅಥವಾ ಪರ್ಚ್ಮೆಂಟ್ ಪೇಪರ್ ಇಂದ ಆಗಿರುವಂತ ಒಂದು ಮೆಂಬ್ರೇನ್ ನ ನಾವು ಇಲ್ಲಿ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀವಿ. ಒಂದು ಪೌಚ್ ನ ನಾವ್ ಇಲ್ಲಿ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀವಿ. ಆ ಪೌಚ್ ಒಳಗಡೆ ನಾವು ಕೊಲಾಯ್ಡಲ್ ಸೊಲ್ಯೂಷನ್ ನ ತಗೊಂಡಿರ್ತೀವಿ. ಓಕೆ, and that colloidal solution is placed in a beaker. ಒಂದು beaker ಅಲ್ಲಿ ನಾವು ಈ ತರ ಹ್ಯಾಂಗ್ ಮಾಡಿ ಪ್ಲೇಸ್ ಮಾಡಿ ಇಟ್ಟಿರ್ತೀವಿ. and here this is an inlet for water ಇಲ್ಲಿ ಎಂಟರ್ ಆಗ್ಲಿಕ್ಕೆ ಇದು ಇನ್ಲೆಟ್. and ಇಲ್ಲೇನಾಗ್ತಾ ಇರುತ್ತೆ, there is a presence of water here, and this is an outlet for the same water ಏನಾಗುತ್ತೆ, through this inlet the water will be entering into this container, and through this outlet the water will be leaving the container. Okay, and we have hanged or suspended a colloidal solution where we took the colloidal solution in a animal membrane or the parchment paper. ಈ ಒಂದು pouch ಅಲ್ಲಿ colloidal solution ಇದೆ. That colloidal solution is impure in nature, pure ಆಗಿರಲ್ಲ, because the colloidal solution will not only be containing the colloidal particles, but it also contains the true solution particles. Now the task is, I need to purify the colloidal solution. How to purify? I'm going to employ the dialysis process here. I have hanged a colloidal solution in a parchment paper so that ಈಗ ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ, slowly the true solution particles will be coming out of the pouch in the true solution particles ನಿಧಾನಕ್ಕೆ ಹೊರಗೆ ಬರ್ತಾ ಹೋಗುತ್ತೆ, and those true solution particles will be washed away along with the water ಆ particles washed out ಆಗುತ್ತೆ, and the solution which is remained in the parchment paper here, ಆ pouch ಒಳಗಡೆ ಇನ್ನು ಯಾವ solution ಉಳ್ಕೊಂಡಿರುತ್ತೆ ಅಂದ್ರೆ, obviously the colloidal solution which exactly contains the colloidal particles, because the true solution particles has been removed here. A true solutions particles ನಾವು ಒಂದು process ನ employ ಮಾಡಿ remove ಮಾಡಿದೀವಿ. Hereby we are purifying the colloidal solution by using the process called dialysis. Hope you got to know about how it is used to purify the colloidal solution. Now children, let us move towards the next question now. The next question, that is the 8th question, is regarding what is coagulation of a salt. Name any two methods by which a lyophobic salt can be coagulated. Coagulation process ಅಂದ್ರೆ ಏನು? coagulation ಈಗ usually sometimes ನೀವು when you'll be run ಓಡ್ತಾ ಇರ್ತೀರಾ, ಓಡ್ಬೇಕಾದ್ರೆ ಬೀಳ್ತೀರಾ, ಬಿದ್ದಾಗ ಏನಾಗುತ್ತೆ ನಿಮ್ಗೆ sometimes ಇಂಜುರಿ ಆಗುತ್ತೆ ಅಂತ ಇಟ್ಕೊಳ್ಳಿ. ಇಂಜುರಿ ಆದ್ಮೇಲೆ ಏನಾಗುತ್ತೆ ಮಕ್ಕಳ, that blood will be coming out of it, ಆ injured part ಇಂದ blood ಹೊರಗೆ ಬರ್ತಾ ಇರುತ್ತೆ, but after some time ಏನಾಗುತ್ತೆ, ಆ blood ಹೊರಗೆ ಬರ್ತಾ ಇರೋಂತ process ಅಲ್ಲಿ ಸ್ಟಾಪ್ ಆಗುತ್ತೆ. ಸ್ಟಾಪ್ ಆಗಿದೆ ಅಂದ್ರೆ ಏನಾಗಿದೆ, the blood has been coagulated there, coagulate ಆಗಿದೆ. coagulation ಅಂದ್ರೆ ಏನು? coagulation ಅಂದ್ರೆ it is a precipitation process. Okay, the process of settling of colloidal particles here is regarded as the coagulation of the salt. How to coagulate? ಈಗ ಕೆಲವೊಂದು colloidal particles ನ precipitate ಆಗಿ ನಾವು ಹೇಗೆ ಕನ್ವರ್ಟ್ ಮಾಡ್ತೀವಿ ಅಂತ ಹೇಳೋದಾದ್ರೆ, a large number of methods are employed here in order to coagulate the lyophobic salts. One is just by boiling. If you keep on boil the lyophobic salt, there the particles, the colloidal particles will be coagulated there, they'll be converted into the precipitate form there. And the other method which is employed for coagulating the lyophobic salt is by adding the electrolyte. When you add a suitable electrolyte there, the colloidal colloidal particles will be settled at the bottom such that the coagulation process can be carried out. Hope you got to know about what is coagulation. If you think of here, children, the coagulation and the peptization, these two are the opposite processes. Peptization andre the process of converting the freshly prepared precipitate into a colloidal solution. Precipitate na colloidal solution agi peptization ಅನ್ನೋ process ಅಲ್ಲಿ carry out ಮಾಡ್ತೀರಾ. But coagulation ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ, the colloidal solution will be converted to the precipitate. ಅದು ಉಲ್ಟಾ process ಇಲ್ಲಿ employ ಆಗುತ್ತೆ. Okay, hope you got to know about the coagulation, children. Now let us head towards the next question. The next question is, what is Tyndall effect? Mention any two conditions to occur Tyndall effect. Tyndall effect andre enu anta. Here a scientist was working on the Tyndall effect, children. Here he has passed a light rays. Light rays na ಒಂದು prism ಮುಖಾಂತರ pass ಮಾಡ್ತಾರೆ. A prism ಮುಖಾಂತರ pass ಆದಾಗ that light has been passed through the container which contains the colloidal solution. A colloidal solutions ಇರುವಂತ ಕಂಟೈನರ್ ಮೇಲೂ ಕೂಡ ಲೈಟ್ ನ ಪಾಸ್ ಮಾಡ್ತಾರೆ. ಪಾಸ್ ಮಾಡಿದಾಗ ಮಕ್ಕಳ the light was scattered there. ಆ ಲೈಟ್ ಏನಾಗುತ್ತೆ, ಸ್ಕ್ಯಾಟರ್ ಆಗುತ್ತೆ. ಯಾಕೆ ಅಲ್ಲಿ ಸ್ಕ್ಯಾಟರ್ ಆಗುತ್ತೆ ಅಂತ ಹೇಳಿದ್ರೆ, because that colloidal solution contains the colloidal particles. Here, children, the scattering of light by the colloidal particles is what is called the Tyndall effect. Then what are the two conditions which are required for the Tyndall effect to arise there? Tyndall effect ಅಲ್ಲಿ ಆಗಬೇಕು ಅಂತ ಏನೆರಡು required conditions ಇರುತ್ತೆ ಅಂದ್ರೆ, the first condition is the diameter of the particle. ಆ ಒಂದು colloidal particle the diameter ಏನಿರುತ್ತೆ that must be equivalent to the wavelength of the light. ಅಂದ್ರೆ ಮಕ್ಳ ಆ ಪಾರ್ಟಿಕಲ್ ಡಯಾಮೀಟರ್ ಮತ್ತೆ ಲೈಟ್ ವೇವ್ ಲೆಂತ್ ಏನಿರುತ್ತೆ, ದೇ ಮಸ್ಟ್ ಬಿ ಸೇಮ್. ಅದೆರಡು ಕೂಡ ಸೇಮ್ ಇರಬೇಕು. This is one condition which is required for the Tyndall effect to occur. Then what is the second condition required here? There must be large difference in the refractive indices of dp and dm. Here when you consider the colloidal solution, there is a presence of dp as well as dm. Dispersed phase will be dispersed in the dispersion medium. Agadi colloidal solution prepare agirutte. And here when you consider the refractive indexes of the dispersed phase as well as the dispersion medium, they both must have a large difference in the refractive indices. Hope you got to know about the conditions which are required for the Tyndall effect to occur. And this Tyndall effect is a property of the colloid. This Tyndall effect will be coming under the property of the colloids. This is one of the property of the colloids, you can see. Okay, now children, let us consider the next question, that is the 10th question. It is saying you that what is Brownian movement, give reason for it. Brownian movement andre eno, adike reason eno, Brownian movement agbeku antandre what actually happens there, yen agutte alli another question. Here makla when you consider a colloidal solution, ಒಂದು colloidal solution na tagondu when you look that colloidal solution under a microscope, ಒಂದು ಮೈಕ್ರೋಸ್ಕೋಪ್ ಕೆಳಗೆ colloidal solution ಇಟ್ಟು ನೋಡಿದಾಗ the colloidal particles were under a constant zigzag motion. The zigzag movement of the colloidal particles of the colloidal solution is what is regarded as the Brownian movement. Actually ಏನಾಗುತ್ತೆ ಅಲ್ಲಿ, what is responsible for the zigzag movement of the colloidal particles in the colloidal solution? Here makla, the colloidal solution, as you know, it will be prepared by dispersing the dispersed phase in a dispersion medium. Dispersed phase na dispersion medium alli disperse ಮಾಡಿದಾಗ ನಮಗೆ ಅಲ್ಲಿ colloidal solution form ಆಗುತ್ತೆ. Okay, and here when you consider the dp as well as dm, the dp also contains the particles, the dm also contains the particles. Here dm particles are larger in size. When you consider this dm particles, they are larger in size. and there will be in a constant motion, constant agi adu move ಆಗ್ತಾನೆ ಇರುತ್ತೆ. When those particles are going to collide with the colloidal particles jothe collide ಆದಾಗ the kinetic energy will be transferred from the particles of the dispersion medium to the particles of the dispersed phase. Kinetic energy alli pass agutte, pass aadaga those colloidal particles are going to gain that energy, gain ಮಾಡ್ಕೊಂಡು those particles will also be in a movement, and that movement when observed under the microscope, that movement was a zigzag motion. Zigzag motion andre in like this, a zigzag motion will be observed in the case of the colloidal solution, and this type of zigzag movement of the colloidal particles in a colloidal solution is what is regarded as the Brownian movement. And hope you got to know the reason for that. The reason for that is it is due to the bombardment of the particles by the molecules of dispersion medium. Whatever I have explained now, that has been formulated you within a sentence. On the sentence alli avaru adana helidare. Okay, hope you got to know about this question, children. Now let us move towards the next question. The last question of this chapter, that is 11th question, has been divided into two. Eradu question agide divide agide. The question is tells you that what is electrophoresis. The question B tells you that state Hardy's-Hughes rule. Hardy's-Hughes rule ಏನಂತ ಹೇಳುತ್ತೆ ಅಂತ ಹೇಳಿ ಅಂತ ಕೇಳಿದ್ದಾರೆ. When you think of electrophoresis, ಈ electrophoresis is a process. ಏನಕ್ಕೆ ಈ process ನ ಎಂಪ್ಲಾಯ್ ಮಾಡ್ತಾರೆ ಅಂತ ಹೇಳೋದಾದ್ರೆ, here this process is employed in order to find out the charge carried by the colloidal particles. ಹೇಗೆ find out ಮಾಡ್ತಾರೆ? How they are going to find out the charge that is carried by the colloidal particles? They are going to keep the colloidal solution in a U-shaped ಒಂದು tube ಅಲ್ಲಿ colloidal solution na place ಮಾಡಿರ್ತಾರೆ like this. There will be presence of a U-shaped tube here. U-shaped tube ಇಲ್ಲಿ present ಇರುತ್ತೆ, and to both the limbs of the U-shaped tube, there they are going to immerse the two electrodes. ಎರಡು platinum electrodes na ಇಲ್ಲಿ immerse ಮಾಡಿರ್ತಾರೆ, such that one of the electrode will be acting as the cathode, the other electrode will be acting as the anode, and these two electrodes are externally connected to the circuit. And what is present here within the U-shaped glass tube? It contains the colloidal solution here. Colloidal solution ಇಲ್ಲಿ present ಇರುತ್ತೆ. What is actually going to take place here? Whenever the circuit is connect ಆಗಿದೆ, the switch is in the on position ಅಂತ ಹೇಳಿದಾಗ, the movement of the colloidal particles will be taking place either towards the anode or towards the cathode. ಈಗ ಈ colloidal solution ಅಲ್ಲಿ ಪಾಸಿಟಿವ್ಲಿ ಚಾರ್ಜ್ಡ್ particles ಇತ್ತು ಅಂತ ಹೇಳಿದ್ರೆ, they'll be heading towards the negatively charged electrode. Negatively charged electrode kadege adu hogutte. Suppose if a colloidal solution contains the negatively charged particles anta helidre, they'll be heading towards the positively charged electrode. Thereby you'll get to know the charge that is carried by the colloidal particles. Here the movement of the colloidal particles either towards the anode or towards the cathode under the influence of electric field. Such a process is regarded as electrophoresis. Hope you got to know about it, children. As I already mentioned you, electrophoresis is a process which is employed in order to find out the charge that is carried by the colloidal particles. Then let me move towards the question B here. The question B is telling you state Hardy's-Hughes rule. Hardy's-Hughes rule ಏನಂತ ಹೇಳುತ್ತೆ ಅಂತ ಹೇಳಿದ್ದಾರೆ. When you consider the Hardy's-Hughes rule, it states that greater the value of flocculating ion added, andre the greater the valency of the flocculating ion added, the greater is the power to cause precipitation. ಈಗ coagulation ಅನ್ನೋ ಒಂದು ಪ್ರಾಸೆಸ್ ನ ನೀವು ಕ್ಯಾರಿ ಔಟ್ ಮಾಡಬೇಕು ಅಂದಾಗ ಈ ಹಾರ್ಡೀಸ್ ಕ್ಯೂಸ್ ರೂಲ್ ಅಲ್ಲಿ ಅಪ್ಲೈ ಆಗುತ್ತೆ. ಈ ಹಾರ್ಡೀಸ್ ಕ್ಯೂಸ್ ರೂಲ್ ಏನಂತ ಹೇಳುತ್ತೆ ಅಂದ್ರೆ, ಗ್ರೇಟರ್ ದ ವೇಲೆನ್ಸಿ ಆಫ್ ದಿ flocculating ion, greater is the power to cause precipitation. When you think of sodium here, for example ಇಲ್ಲಿ sodium ಇದೆ ಅಂತ ಇಟ್ಕೊಳ್ಳಿ, ಅದ್ರ ಜೊತೆಗೆ ಮಕ್ಕಳ think of magnesium that is present here, and as well as magnesium is carrying +2 oxidation state. And when you think of aluminum ಇಲ್ಲಿ consider ಮಾಡ್ತೀನಿ, aluminum will be having +3 oxidation state here. These are the ions. These ions are regarded as flocculating ions ಅಂತ ನಾವಿಲ್ಲಿ ಕರಿತೀವಿ. When you think of this flocculating ions, what is the order, increasing order in order to cause precipitation? ಪ್ರೆಸಿಪಿಟೇಷನ್ ಅಲ್ಲಿ ಆಗ್ಬೇಕು ಅಂತಂದ್ರೆ ಈ ಅಯಾನ್ಸ್, ಮೂರು ಅಯಾನ್ಸ್ ಅಲ್ಲಿ ಯಾವ್ದು ಫಸ್ಟ್ ಪ್ರೆಸಿಪಿಟೇಷನ್ ಪ್ರೋಸೆಸ್ ನ ಕ್ಯಾರಿ ಔಟ್ ಮಾಡುತ್ತೆ ಅಂದ್ರೆ, ಇಟ್ ಇಸ್ ಅಲ್ಯೂಮಿನಿಯಂ. ಅಲ್ಯೂಮಿನಿಯಂ ಹ್ಯಾಸ್ ಗಾಟ್ ದ greater valency, it has got the greater value of the flocculating ion idagirutte. So it has the power to cause more precipitation. Okay, then idadmele yaad barutte, idakke jaasti ide anta helidre, next yaad barutte, next comes magnesium, which is having +2 oxidation state, and after that comes sodium, which is carrying +1 oxidation state. Hope you got to know about what is Hardy's Q's rule. Now hereby children, hope you got to know about all the important questions which are going to appear from the chapter surface chemistry. All these questions are important as a point of view of your exam. Hope you got to know about all the questions. Thank you all for the session children. We'll meet up in the next session.